we are still busy with integration by parts, but we're going to look at a couple of examples that are slightly different. So in the given example here for part A, find the integral of the natural log of x dx. Now, if you haven't come across something like this yet, you would not necessarily know what to do. Luckily for us in this case, they have guided us to say we should write natural log of x as 1 times ln of x. So the moment I want to go and solve A, so if I have the integral of 1 times natural log of x dx, it is actually easier to solve. So what we're going to do is we're going to say let u equals natural log of x. So du dx is going to give us 1 over x. Then also we're going to say let dv dx equal 1. That's why we introduced this 1 here. And then if we integrate this, then v is going to be equal to x. So now for this integral, so of course you can use the formula, but we know that it is u times v. So in this case, it is x times natural log of x minus the integral of du dx times v, which in this case is, so if we have 1 over x times x, this is just equal to 1. So 1 dx. And of course, if we were to expand or finalize this integral, we're going to get x times natural log of x minus x plus c. Now, I'm not going to simplify it. I will leave my answer as it is here for the moment. Now, for part B, and this is where it gets slightly interesting. Hence, so knowing this first part, find the integral of natural log of x whole squared. So let's go and move down slightly to get some space. And then let's go and start with b. So here, again, we've got the integral of, and I'm going to write immediately this 1 times natural log of x squared dx. And I will follow the same procedure, but in this case, I'm going to say let u equals natural log of x squared. And let dv dx equal to 1. So this part is easy. V is equal to x. And then du dx, so the derivative of this. Now, in this case here, I will have to use the chain rule. So the power times in the front multiplied with the derivative of the inside. And this will give me 2 natural log of x times 1 over x. Now, let's go and rewrite our integral. So this is equal to u times v. So x multiplied with ln x squared minus the integral of du dx times v. Now again, we have, I'm going to underline this with the red. So x times 1 over x is just going to give me 1. So in other words, we're going to get here minus 2 natural log of x dx. Of course, this 2 is a constant, so I can take this constant out. Now, if you notice, what do we have here? We have the integral of natural log of x, which we have actually solved above already. So the integral of ln x dx was the following. This was the answer that we got for the integral of ln x dx. So now we can go and say, sure, x, and I'm going to leave it all as it is. I'm not going to simplify it, minus 2. But now instead of this, I can actually use my previous answer. That's why the question said hence. So using the first, we can go and solve the second. X times natural log of x minus x. And of course, all of this plus c, which is our arbitrary constant. All right. You can just simplify this, remove the brackets x ln x squared. That bracket I will leave there, minus 2x natural log of x. All of this is multiplication plus 2x plus. Okay, so that is relatively straightforward there because we have used the previous answer in this case. After this, I will make another video with some more examples.